Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.fm radio. That means it is another Friday evening. This one is May the 31st, 2019, 9 o'clock in the evening, Daylight Savings Time. For those of us here in the eastern portion of North America, Universal Time would put it at, what is it, Universal Time? 1 o'clock in the morning. June the 1st, Saturday morning.
2 o'clock if it's British summertime.
British summertime, that's correct. My name is Marty Coons with my co-host.
Good evening, it's Nicky Vetz. 2 Echo Zero, Lima Uniform November.
Don't forget, come on over to our chat room. You'll find it at our homepage, astronomy.fm. Just scroll down to the bottom. It's real short. You get to the chat section. Erase anything that would be password. So all you need is a name and hit login, and you'll be here. Come on over and join us during our live presentation. Always a lot of lively conversation going on in our chat room. And if you have any questions for us, you can type them into the chat room. And feel free to ask us a question. We'll try to answer you live on air.
Well, we've already got a link in the chat room, Marty.
Is there already a link in the chat room? Oh, yes, somebody already put one in there.
Yeah. So let's introduce the people who are in the chat room.
All right, go ahead.
So there's myself, Sky Guide Nick, Sky Guide Marty, Khan again, Glenn, and Starstorm in the chat. If you're not in the chat, you're missing the links. You're missing all the great conversations and all the fun. And of course, this show will be YouTubed tomorrow, and thanks to Starstorm, who's catching the links for us. The links will be with the video on the Event Horizon channel on my YouTube account.
YouTube channel, okay.
Yeah.
And the links also go to our AFM Facebook page too, right?
No, because
they don't go there.
They don't go there for one simple reason, Marty, because Facebook corrupts them.
Facebook what?
Corrupts the links.
Corrupts the link. Gotcha.
Basically, anybody who's followed the Space Pirates knows that Pladmac posts the links on the Facebook page for Space Pirates. The only problem is when you go to click on them, they don't work.
You get a 404 error. Yeah, it depends on how you put some of the links in there. It's like there's ways of putting them in that makes them work, but we have to fix that a little bit.
Well, as I say, the greatest thing about doing a YouTube video is that in the description box, you can put a few words of chat and put the links in there, and they survive quite nicely. And if I can get my sticky little mitts on the pirate shows, I would set up a YouTube channel for the pirates, and I would post them there as well, just because I'm a sucker for hard work.
Mm-hmm. Oh, we got to welcome Torb J that just came into our chat room. Welcome back again.
Yeah.
Oh, where do we want?
Glenn points out, so be there or be a square, or be square.
Yeah, be there or be square. What's be square? That would be, I know what.
Isn't that 2x delta or something?
Something like that, yeah.
Unless, of course, you're on a spacecraft and it's call sign X-ray Delta 1, which was the ill-fated US Discovery, the HAL 9000 in charge.
There you go.
Of course, all I want, Marty. I can't get it.
Okay, what were we talking about?
Well,
chat, links and stuff. Yeah. Oh, yeah, go ahead. Start over.
Well, we've got one link in chat. It's about an astounding amount of water on the Martian North Pole. That was put in by Khan again.
Mm-hmm.
And using ground-penetrating radar, scientists have detected a massive reservoir of frozen water. Okay, it's sandwiched by layers of sand beneath the North Polar ice cap. this reservoir has so much ice in it that if melted and brought to the surface, it would actually make Mars a water world. So
That's
useful. Yeah, but you got to build floating colonies, and where are you going to land your spacecraft?
Mm-hmm.
Yeah, we could do platforms. We can do a Musk, who's in everybody's bad books at the minute. Well, he's getting that way. I've actually heard professional astronomers who are now getting really upset with him over his Starlink project.
Yeah, but he's saying that they haven't reached orbit yet, and they'll be fading considerably.
Well, we're digressing a bit, but let's go there. The problem is some of the flares that have been seen already are two or three times brighter than some of the older Iridium satellites.
Mm.
So this is only the first 60. He's planning 1,200 satellites in a grid pattern around the world, which means the Star Labs, who does nebulosity, PixInsight, Maxim DL, are going to have to do some really, really hard work and to modify their processing algorithms to pick up and eliminate streaks and blobs of light from these satellites.
Mm-hmm.
A lot of people were thinking, oh, it's not going to affect imaging. And I know last week we discussed it. But the evidence that's emerging so far, and this is only from the first 60, that is maybe this is going to be a major pain in the whatever to ground-based astronomy, and particularly to imagers, because it could even start altering the constellations as we see them.
Well, these are going to be in orbit, not geosynchronous, right?
They're going to be mostly in low Earth orbit.
Yeah, so they won't affect the shapes of the constellations that way.
Well, as I say, the complaint is being that when you're something to image, because a lot of programs, particularly like Astrometrica, are looking for certain stars in certain positions so that they can actually figure out exactly where in the sky the image is taken from and what the image actually contains. They're concerned that programs like Sinbad, Aladdin, Astrometrica may have an awful lot more problems actually figuring out what is actually a genuine celestial object and what is somebody's attempt to give cheap internet, broadband internet to the world.
Well, anything more than a couple seconds should show elongation to prove that it's a satellite.
But the problem is, if you're doing a long exposure on a CCD for a very faint galaxy or something, it is going to really, really interfere with what you're doing.
It's possible, yes.
So apparently, at least 3 well-known names, one of which is on Twitter, is gathering the troops, according to my information, and she has already kicked off about it, and she is not a very happy camper. I am not going to bring names into this because of what's going on, but all I can simply say is the person involved is a professional astronomer who is probably seeing the chances of doing ground-based work disappear, because everybody was taught, it's going to be predictable, they're going to be between dawn and dusk. Well, if you're searching the dawn or dusk skies for a comet, and that satellite decides to flare when you're looking for, as you actually find the comet, you're going to lose it. Or even worse, if you're trying to do a series of observations on a variable star for the Hubble team, and this thing flares up, it is going to be a nightmare because the Hubble team depend on ground-based astronomers to actually to put in the rewarding work of timing variables, plotting magnitude graphs, so that when they come to point the Hubble in that direction, they have a very good idea of the variability and time scale it takes from going from minima to maxima and back down to minima. So this could be a real potential pain when you're doing that. I'm going to say this. I like the work the guy is doing to actually get us back into space, but I don't think putting all these satellites in orbit in such a grid is going to help. Why are they called iridium? Because I forget that there was a very good reason. I think they actually use iridium metal on the solar panels. But let me just quickly Google that.
Well, these aren't iridiums. The previous ones were by Motorola were iridiums.
Yeah, Glenn is asking that question in the chat room.
Yeah.
Okay, iridium. Iridium communications. Okay, let's have a look here.
Iridium's one of those minerals that are mostly found out in space. I don't know if is it found at all on the Earth or very rarely? But
it is found on the Earth, but not as much as other elements.
Out in
the thing
space.
is, well, out in space, it is probably perhaps more common. The reason we know this is because of the KT boundary. When the Chicxulub impactor hit the Earth, one of the things that appeared was a band of iridium. And that's what allowed them to actually date it.
Mm-hmm.
But as I say, I'm just trying to find out if there's a reason if it's just the name they picked for the system, or they actually use the material in their satellites. But
maybe it just sounds spacey enough to use it.
Yeah.
So let's see if they have a reason, or what they give as a reason for it. So
yeah,
if they ever gave one, it was just a name.
I think it was just something they picked as being a cool name, and it may be that some of the metal is used on the solar panels or something.
Maybe, or maybe it's because Klingon was already taken. Glenn's question: what do you think is our greatest threat from space? I think it's still people. Is our greatest threat from space. Stuff we put up there and stuff that could come down on us.
I think the biggest threat in space is actually the junk we have in the Clark Belt. And the fact that most nations seem to think that they have to flex their muscles and show us how good they are at space by blowing an old satellite out.
Mm-hmm. That's what I'm saying. I think it's our own people that are our greatest threat from space.
Pardon?
What?
Starstorm, come a bit closer.
Oh, it's nothing to do with the show.
Oh, it's nothing to do with the show. Okay. Sorry, I thought you were talking about what we were discussing.
No,
Gamma ray. One Khan says Khan's idea is a gamma ray burst hitting us. Kind of rare for that one.
Yeah, we're not really in the firing line.
Yeah, there's still a pretty good chance of a good sizable asteroid hitting us.
Yeah, a piece of rock or a bit of space junk.
That's probably on the top of the list. Yeah,
A
big enough rock.
Yeah,
or comet. Obviously, kind of the same type of thing. What other threats are there from space? Obviously, the potential of aliens, including simple alien bacteria or some type of life that's not compatible with us, and it basically eats all the life on the planet. That's always a potential threat. Massive solar flare is a potential threat, mostly from our technological standpoint, in that we have maybe a little too much technology to deal with a massive solar flare and be able to survive its after effects for that. Well, we could survive it. It's obviously a pretty survivable thing. It's just definitely reduce our technological capabilities, which might not necessarily be a bad thing. What other threats are there? We don't really have to worry about supernovas. Nothing close enough in the area to worry about something like that.
Saying that, There's two candidates we're really waiting for to kick off and give us a display. One of them is Betelgeuse.
Yep.
That's going to be fairly spectacular, and of course, the other one is in the southern skies. And it is
What's that one.
Oh gosh, I remember its name because I've imaged it so many times.
Rho-Ophiuchus, maybe?
No, Rho-Ophiuchus is too far out.
Yeah.
It's the Homunculus Nebula.
Oh, yeah.
Of that, the heart of that.
Okay.
Because that thing seems to pulse, and maybe that is getting ready to kick off again, and really put on a light show. But it will be interesting. I'm just trying to remember what the heck that galaxy was. That planetary nebula was surrounding.
Another potential threat is excessive cosmic radiation.
Yeah, but that would require the sun to undergo a drastic change to really kick off.
Well, that's from the sun. There's still, galactic cosmic radiation and stuff like that still get cosmic rays. Still do some damage to us. We're getting more of them now with being at solar minimum. And depending on our position in the galaxy too, that affects how much cosmic radiation we get. So I think we're getting into more of a vulnerable part of the galaxy. So we're maybe steadily increasing our exposure to cosmic rays. There's always a point of getting zapped big time from them. Not direct contact, but the after showers and stuff like that. What else is bad for us from space immediately being in our semi-safe place here on Earth?
Well, maybe a nuclear power satellite.
Yeah, that would be one of our own though. So let's see. I don't think that's mostly it. Obviously, space itself is pretty dangerous, but we've got some pretty good shielding in many different forms. I don't know, I can't think of anything else that would really be a major threat from out in space to us here on the Earth. We're very little chance of something like a star getting close to us or a black hole getting close to us to disrupt the planetary orbits or disrupt the Kuiper belt or Oort cloud.
That would require something large to go past the edge of the solar system to really cause an influx.
At just the right time and place to do that too would mess us up, but that's a pretty rare one.
In fact, here's an article here. What would happen if Betelgeuse went? There you go. Basically, it's the brightest red supergiant in our entire night sky. It supposedly could go supernova at any time, and
I think it's far enough away for us to not worry about, though, right?
Not really. It's far enough away that. But from our perspective, if it did, it would be a very, very bright one. Everybody says, "Oh, it would be nice to have something that would really shine during the day." Well, this would be possibly one that would do this.
But I think it would cause a lot of anxiety losing a major star in a major constellation like that, though. It was just like,
oh yeah, but you know what? It's going to happen.
Well, yeah, it's going to happen.
Because I do believe that the Crab Super Nebula was visible to the Chinese during the day.
The Crab Nebula.
Yeah.
Yep.
Because the Chinese did record it. So as I say, Betelgeuse is what, 600 or so light years away. It would be
so.
By far the closest of any supernova ever recorded. But it is still nicely far away. It's not a real danger to us.
Right.
So, as I say, it will certainly be interesting. We're quite lucky in some respects that we don't have an ultramassive Wolf-Rayet star close by as well. So, that kind of helps too.
Yep. So I say the number one threat would be an asteroid or comet.
Most likely, yeah.
most likely, and most likely to happen, and definitely human life eliminating type of event.
Well, you know what? They're gonna at some point they're gonna happen. We're gonna have a real extinction event,
Mhm.
and we're actually gonna know about it because we'll be around to record it.
Mhm. Did you show those Australian videos yet?
Not yet, no.
Oh, let's
Well,
go
yeah,
that. Let's go that way. Then we'll get back to Mars. I get more stuff on Mars, but since we're talking about asteroids, we just happen to get that way.
Yeah.
Let's go with the stuff that's actually hit us lately. It's been some pretty cool.
Well, actually, they reckon that the amount of stuff that's coming
meteoroids
through has been going up.
Yep.
So anyway, as of the 22nd of May, a meteorite suspected as
Meteor.
a fireball.
Don't read
Meteor,
it. Meteor.
thank you, yeah, meteor. Was suspected as a fireball. It was filmed in the Australian night sky with sightings in 2 states. In fact, it was so bright. It was described as a bright white light crashing into the ground. It was captured on a dash cam by Dylan Bishop, south of Adelaide, at about 10:30 p.m. local time of that night. One Facebook user described it as a huge bright white light, while another said it scared the stuffing out of them. I've seen about 2 different videos of this. One of them was one of those really smoochy, pseudo-sciencey voice ones where it really... Okay, so I decided that I was actually going to go investigate it. I actually contacted a friend of mine, Rich Kowalski, and asked him if this was really, really true. And he looked at it, he said, yeah, it looks like it is the real deal. And then he pointed me to a better story that was a lot less hype and a lot more science. Thank you, Starstorm. So anyway, it's been described as being a possible meteor. It's probably about not very big, but big enough that it put on a really wicked show. The other thing, of course, is we still don't know if it's a Taurid. That is still out. But the interesting thing is, it wasn't quite as... They don't think it was quite as big as Chelyabinsk. So anyway, there was also another sighting over Tennant Creek, which is more than 500 kilometers north of Alice Springs. So CCTV footage from Safety Beach on Victoria's Mornington Peninsula shows a huge ball of light falling from the sky and illuminating Port Phillip Bay. So they think any debris from the detonation is actually in the Great Australian Bight, which is underwater. So it's a meteor, it's a small asteroid that's created this according to David Finley, who administers the Australian Meteor Report Facebook page. He believes people have seen a small meteor.
Small asteroid? Or
he's saying a small asteroid.
Be a large meteor or small asteroid. I mean, some of the asteroids in our asteroid reports are down to like 10 feet. They're calling, well, I don't know if they call it an asteroid, but they're near Earth object. They're semi-calling them an asteroid if they're 10 feet in diameter, but I would say no, more of a meteoroid in space.
One of the reports for the second one, I believe, it was described as a 3 to 4 second phenomena about 10:40 p.m. And this is what he told ABC Radio Adelaide. There was a green tinge to it at the start, and I saw the whole ball pass across the sky heading south. As it disappeared towards Willawonga, it actually increased in size. It seemed to be breaking up, and it got larger as it disappeared over the hills.
That's the brightness glow that got larger, not the actual object, because you can't really see the actual object.
So now this isn't the first one for this year. There was another suspected meteor spotted in Adelaide skies in March of this year, and Let me just get a link for that one.
Okay. Yeah, Australia's been kind of hit a little bit more often than normal recently. So, well, that's kind of cool. They got a lot of open areas good for meteor hunting too. So.
Well, yeah, I would not be surprised to hear that the meteor men have been down there looking for bits for their collection.
Mm-hmm.
So the second link I put in, again, is from ABCnet. It's a lot less, how can I put it, funky, overhyped. It's actually been written as the observations and left at that. One of the descriptions was it was flaming orange, turned green, then burnt out. Maybe it gave me a bit of a surprise. The sighting has occurred as far north as Port Pirie, where the object's relatively slow trajectory was captured on video. So they did contact an astrophysicist at the Australian National University. Dr. Brad Tucker said it's unlikely to be space junk. That has a very different characteristic. People often see it flaking apart.
Mm-hmm.
So it's clearly not as destructive as the one that exploded over central Russia back in 2013, but such objects needed to be tracked and understood. And in fact, there is some very nice pictures of bits of rock that have been captured since. Now, what it is, of course, the upside of this is Woomera is being reactivated. Woomera will be used for nano satellite testing this week, rather back in March it was. So, hi new gazer, welcome to the chat room and welcome to the show. So, of course, and Adelaide is going to be the home to a mission control centre after it secured hosting rights for the new Australian Space Agency. The Australian federal government has made the announcement on Monday. It's promising to invest $6 million to establish the mission control centre. And you know what? I say bloody well done, mates. It's going to be a more modern version of Houston, says the agency's director, Dr. Megan Clark. It's the first national mission control for Australian space. We'll be able to connect and talk to Australian assets in space. There's going to be a space discovery centre on the eastern CBD, and space startup companies from Australia will be testing satellites and other technologies in the Woomera test range out in the outback. Is it nice to see Woomera activated again? Yes, it is. Because it means that we are looking at a very, very good place to launch satellites. The old British Space Agency, prior to just before Apollo, would ship our rockets, our Black Knight rockets, over to Australia to launch. And one of the main satellites that we did launch was Prospero. Prospero is still in orbit. It's still functioning. And if you track it, I think it's somewhere around 136, maybe 137 megahertz. You can hear it every now and again going beep, beep, beep as it goes overhead. It's still sending its signals to say, I'm here, I'm functional. And
Like the rovers.
like the rovers, yeah. So, as I say, it's nice to see such technology surviving.
Yeah, indeed. By the way, you're listening to the Event Horizon here on Astronomy.fm radio halfway through our program. Still got another half hour of live programming, so glad to have you all listening. It is, just to let you know, May 31st, 2009. I was looking at the date. May 31st, 2019, and the time about 9:30 in the evening for those of us here in the eastern portion of North America. So that would put it at about 1:30 in the morning, Universal Time, Saturday morning, June the 1st. June already. Well, time flies.
Mm-hmm.
So coming up on another 3 weeks up to the June solstice. We'll talk more about that as we get closer to that time, what that really means and stuff like that. I want to say hi to everybody in our chat room tonight. We got a good crowd going on here. We got you and me, Nick. We got Con again, Glenn, Starstorm, Torb J and Newgazer 911 just joined us. Glad to have you all here listening in. Thanks for coming in, everybody. If you want to join in our chat room, feel free. Just go to the homepage, astronomy.fm, and you'll see down near the bottom where you can click on it and log in. By the way, erase anything that might be in the password. You don't need that, and actually gets in the way. I've got more programming coming up after the event horizon, so stay tuned for more stuff. And we'll repeat all these programs every 4 hours for the next 24 hours. And if you want to get the links, go to what is the name of your YouTube page there?
The YouTube channel is the event. It's actually not on my main YouTube page. So you need to look for bedfordshire.astronomer@gmail.com. On YouTube, and you will see our gallery of shows. There's also Comet Watch there as well, and of course, Comet Watch has its own channel, and of course, Under British Skies has its own channel, and we are actually recording a show on Sunday.
Great. Yeah, Newgazer is mentioning about passwords, having too many passwords. Yeah, I have lost more contact with more groups because I couldn't remember their passwords or my login name or everything else like that. It's like, frustrating. So you get a computer, everything goes in your computer, and then you can't put your password in the computer anywhere that you could get to it because you need the password to get into the computer. It's a vicious cycle.
I have no problem remembering the password to access my computer. I can remember that.
Sometimes I put in passwords, and then next time I go into a site and I log in, it says I can't log in because somebody already has that name and password. Yeah, it's like, yeah, it was me. Stupid.
See, I use a hexadecimal code. My password is a hexadecimal code.
Hexadecimal code?
Yeah.
I want to use
letters and it's got numbers.
I want to use hieroglyphics, but I can't find those on my keyboard. I could probably get away with, like 3-letter password in hieroglyphics because I'm not too sure anybody uses them. Oh, well, I need a new keyboard. I wonder if they got an ancient Egyptian keyboard. Now, that would be fun.
Well, actually, I do believe there is a keyboard you can download. Okay, so my computer has a Korean keyboard, Chinese traditional, Chinese simplified, Japanese. The system keeps offering me Vietnamese as well to add to my collection. So that all I'm going to do is mouse over to a tab that says EN, and then and I can click on that, and then it lets me pick my new keyboard. So when I type, I'm typing in a different alphabet.
There you go. Yeah, I guess you could change languages.
Yeah.
But you can't read your own messages that way. That's part of the problem.
I don't have a problem with it. I can read languages better than I can speak them. Okay, another thing that I meant to mention last week is that there is an ongoing disruption of the Great Red Spot.
Yes.
And here is the British Astronomical Association page. And speaking of spots, Starspot comes in. How's that for magic? Just like that.
There you go.
Okay, so what's going on? Activity around the Great Red Spot is particularly interesting and rapid changing at present. As you can access the previous reports. There's some updates, some text, figures, and additional links. Basically, looking at some of the animations I've seen on articles, and they're on Facebook, there is an awful lot. Okay, let me just grab this link. Hopefully it will work. This is from Alpo. No, I don't want to save it.
Association of Lunar Planetary Observers.
Yeah. This is, let me just grab that link. There we go. Cut and paste is always. There, now. I'm going to make sure it works. Yes, it works. Pages, there we go. So this is the Jupiter 2019 apparition and its activity of the Great Red Spot regions by Shinji Mizumoto and Kunaki Horikawa at Alpo, Japan. So there is some quite interesting details being seen, and there are changes happening. And of course, some of the text is in English, and the text is in English and Japanese. So, and there's even images from Damien Peach, etc. So, as I say, have a look. If you have a telescope and you can image, take some pictures, send them to the Jupiter section of the British Astronomical Association.
Yep. Of course, one of the best ways would be to hook a video camera to your telescope, shoot videos of it, then use some processing software to combine the best frames, get rid of the bad frames, and really improve your imagery. Because you're going to have to zoom in a lot to get some detail in the Great Red Spot. Now, your eye can kind of pick it up a little bit better than video. And then you get fleeting moments of clear and fuzzy and clear and fuzzy. So the best way is to get a good image is doing it with video and the proper software to get rid of the junk and combine all the good stuff together. And you have to have an exceptionally good, steady night for it. Northern Hemisphere observers are going to be having issues with Jupiter in high detail because the ecliptic is riding very low in the early part of the evening to our southern horizon. So, and Jupiter is right there in the constellation between Scorpius and Sagittarius. So it does not get very high in the early part of the evening in there. So that means more atmosphere, more turbulence, and a lot harder to get some really good, clear images of Jupiter that way. So you're going to have to, get some good local conditions where you've got a good, as steady as possible batch of air to look over locally, plus long distance away too.
Now, the other thing, of course, is the STB Spectre effect on Jupiter is also affecting the Great Red Spot. This is a publicly selected target. It's called STB Spectre. It's a ghostly bluish streak across the first half of the image. Now, I'll just put the link in that I just pulled up from physics.org.
Okay.
Yeah,
by the way,
a lot of dedication and patience.
Yeah. Mid-northern hemisphere for us, Jupiter's rising only about 10:30 in the evening, so that does make it a fairly nice early evening object to look at just after it's getting dark, summertime now.
So the link's in the chat room. There's a very nice picture, and it highlights a feature where multiple atmospheric conditions appear to collide.
Mm-hmm.
I think this is one of the fun things about Jupiter and Saturn to a lesser degree. Jupiter's always been nice to observe because, that's right. You're quite correct, Starstorm. It can throw up interesting effects at short notice. Some of them are extremely long-lived, like the Great Red Spot. That's been observed for over 150 years now.
400.
Some of the 400 years.
Back to the Galileo times, yes. So ever since Jupiter's been seen with a decent telescope, it's had the Great Red Spot on it.
So, and the other thing is, as Starstorm quite rightly points out, we never know when we're going to see a wound in the form of a comet or a comet nucleus that's been shredded, like Shoemaker-Levy 9, and
that's
that
right.
impacts.
Yep.
2009.
Yep.
Partly we have a good shot. If something happens now, we've also got a good shot because the Juno mission is still active and orbiting Jupiter at a highly elongated orbit. I think it gets about every 6 weeks or so, gets close to Jupiter and gives us a pretty good view of the planet. So hopefully its next pass, whenever that's due, got to be coming up pretty soon, will give us a decent view of the Great Red Spot region. Maybe we'll be able to see what some of that disruption is going on there.
As I say, this is one of the fun things about astronomy. Even amateur astronomers can get in on the act, and most certainly imaging Jupiter from home is not a big issue.
Mm-hmm.
In fact, with a reasonable sized telescope, you can get some quite decent images. You can also visually observe and draw using blanks with the Jovian belts already marked in what exactly you're seeing and where. And a lot of places provide those blanks. The Sky at Night magazine, I believe, has blanks for Jupiter and Saturn, where you can actually just is literally photocopy them out and use them at your telescope for sketching. So it is one of those lovely places where you can actually sketch what is going on the planet. You can do the same thing to a lesser degree for Saturn. You can certainly do it for Mars. And of course, a lot of people still sketch lunar craters under differing light conditions, because this is when you actually get to see a different aspect of the planet.
I tried sketching the moon one time, but there's just so much detail there. I found it pretty much impossible.
Yeah, well, what you do in that case, Marty, is you just concentrate on, you pick a crater or a feature that you can find easily, and then you make sketches over a period of time as the Terminator moves across the face of the moon. What you're going to see is going to be very, very different on a regular basis. It is a very changeable place. Which actually brings me to another story I found.
All right. Well, we've got on the moon, or we're going to do Jupiter, because Jupiter's got a news article too from Juno.
Okay, go with your Juno article.
All right, let's do that. Let me pop this into our chat room here. Oh, come on, highlighter.
Yes, Glenn, reclaim the boxcars. All that material that was used to build Apollo, if it's still in existence.
There we go. Juno's discovered some changing magnetic fields. Jupiter's discovered the magnetic fields of Jupiter are actually changing over time, and it's because of the planet's deep atmospheric winds. So the article's from NASA. It's in our chat room.
Yeah, and it shows that there's an invisible to the eye concentration of magnetic fields near the equator. It shows up as a great blue spot. So the still form is from an animation that illustrates Jupiter's magnetic field. Jupiter is probably one of the most difficult planets to visit for humans because of the intense radiation belts. The closer you get to the planet, the more intense the radiation field is. And of course, that was one of the things that Juno was actually built to withstand, was the radiation when it dips in close to the planet on its orbit. And so far, the technology is held up pretty darn well.
And the images coming off of Juno are actually put out there immediately for amateurs to basically image process them. And a lot of people image process some very interesting detail out of the Juno mission images. Well,
yeah, because the thing is, NASA isn't processing most of the images we see aren't processed by NASA. They're actually processed by amateur astronomers using exactly the same software that they use at home for their images.
Some missions in the past were actually exclusive to scientists, satellites and stuff like that. Like the scientists would get the data from one of our satellites, and they would have exclusive rights over it for a certain period of time before it was released to the general public. But not Juno. The information is released immediately to the general public. That's a bonus right there.
Yeah. Well, Glenn's saying is, how do you negate radiation? Well, one of the things that's been discussed certainly for long-term missions into the solar system is using a magnetic field around the spacecraft, creating a torus to deflect. Yeah, guess what? We found a deflector field that we can use that's very Star Trek-ish.
Maybe they're using vacuum tubes.
Well, that would be certainly good for the electronics on board, because the vacuum tubes are actually not damaged by radiation. The radio transceiver that's sitting on my desk as I talk is a 1970s transceiver. The finals on it are valves, which means it can take a massive amount of power reflected back into the transceiver and not blow. Also, it means it's previous to an electromagnetic pulse. But a lot of the things they're talking about is a very Star Trek-like deflector shield that they can use, particularly if there's a violent solar storm, to protect the astronauts on a long duration mission.
Mm-hmm. Oh, a couple. Go ahead.
So it's kind of ironic. Star Trek yet again is becoming real. They brought us the flip phone. Then NASA is actually building a workable tricorder for the ISS, which will no doubt be super refined for other missions. What can we say?
Just want to say I want to welcome a couple more people into our chat room. Star Spot, and somebody logged in without a name, which you can do too. You get a number. They're 290-417. So if you don't want to type in a name, that's perfectly fine. Of course, when you type it in, you don't have to use your real name either. Just make sure it's something that we can read and it's polite.
Yeah, family friendly.
Mm-hmm.
Okay, so another story we found. Well, I was looking at this before we came on the air.
Okay.
It's from astronomy.com. Hiya, Dave. Great magazine, mate. Okay, our lopsided moon was likely hit by a dwarf planet. Now, basically, the theory is the moon was forged in a cataclysmic collision between the Earth and a Mars-sized planet called Theia. Apparently, they think now the moon may have taken a second blow from a dwarf planet. So they're talking about it, what's caused the two sides to be different. So Meng Hua Zhu from the Macau University of Science and Technology says that a dwarf planet striking the moon sometimes after its initial formation may have caused the lopsided world we see today. It is a lopsided satellite. There's no getting away from it. It's not a sphere, a perfect sphere. It is actually lopsided. So, like I say, sometime in the Earth's early history, a planet-sized body nicknamed Theia struck our planet, throwing material into space, where it coalesced into the moon we see today. But even this can't explain the differences between the Earth's moon and the difference between the near and far sides. Well, one part of the explanation is kind of the late bombardment, because the other side of the far side of the moon, not the dark side, that's a Pink Floyd album, the far side took a heck of a lot more punishment than the near side did. So the postulation is, over the years, as both sides suffered numerous asteroid strikes, the near side cracked open. An outpouring of lava filled basins and hardened into the mare or plains we see today. But the far side has a thicker crust, so there's just a lot of cratering. But the puzzle is, why the two hemispheres have different thicknesses to begin with is the one that's harder to explain. So one way to actually solve the problem is if a small world about, say, Ceres size, which resides in the asteroid belt, would have hit the moon's near side after it had already been formed and solidified. The impact would have thrown up material, and as the material resettled, it would have fallen mainly on the far side of the moon, burying it under 3 to 6 miles of regolith. So Zhu and colleagues ran a series of computer simulations to test the scenario and found that an object ramming the early moon at between 14,000 to 15,000 miles an hour would recreate the moon as we see it today. That may sound fast, but it's only a quarter of the speed of most small meteors that hit Earth. It would also help clear up some of the long-time standing questions about materials that make up the moon. Both very Earth-like in some ways, a sign that the moon did actually form out of Earth debris, and dissimilar in other ways, pointing to additions from an outside world. Anyway, this is what they call a three. This is it makes it a composite of three different bodies. It's a different sort of three-body problem. So have a look at the article and think what you think about it. Yeah, have a great weekend, Con. So it is very thought-provoking. Did something the size of Ceres hit the moon early on? It does look like that is now quite possible. Having said that, it's probably better that it hit the moon than us, because given the state of the Earth at that time, it was finally beginning to solidify. Water was coming into the equation. So a major collision like that again would have possibly disrupted the Earth, and it would have perhaps delayed life as we know it for quite a while. Sorry, I had to get the Spock bit in.
Mm-hmm.
But it is worth having a good look at and having a good think about.
Yep. So, more information, slightly changing our understanding of the universe around us.
Yeah, it does. And I think this is the thing, because of the capabilities of the supercomputers today, we're actually able to run millions and millions of calculations, millions and millions of simulations, and find one that actually works.
Mm-hmm.
So it is good, and it perhaps will help us explain an awful lot. And maybe when we look at other satellites, which are perhaps just as pockmarked and cracked and damaged as our moon, that may help us explain what happened to them as well. We know why one certain planetary moon has a series of craters in line, because we know that Jupiter occasionally does disrupt comets, and then they go in as a chain, like Shoemaker-Levy 9 did. Sometimes the comets get to miss Jupiter, and they may actually end up creating a line of craters in a straight line. We have seen that on the moon, and I do believe that Gene Shoemaker actually found a series that matched that on the Earth too. So Shoemaker-Levy 9, it was a major wake-up call, and it explains why we have things like NEOWatch, NEOShield, SpaceWatch today, because when this was one of the first times we actually got to see what a decent-sized comet could do to a planet.
Yep.
And the actual real-time damage we can actually see the damage in real time. Every time there was an impact with Shoemaker-Levy 9, it was being shown almost instantaneously all around the world. There was no pause for the scientists to have a look at the pictures and think about it. The pictures were being coordinated and gotten out to the press very, very quickly.
Mm-hmm.
I do believe that perhaps SpaceWatch was SpaceWatch really, I think, came in at that point. But the thing is, it made Senate and Congress wake up to the fact we need SpaceWatch. It does fulfill a very vital defensive function. It allows us to see and perhaps anticipate something that could actually do a heck of a lot of damage to this planet.
Let's see. Oh, by the way, SpaceX Dragon spacecraft, which is attached to the space station, will be leaving the space station Monday morning, June the 3rd. So you could probably watch that on NASA TV.
Right, we need another story, don't we, Marty?
We got 7 minutes yet, so we got time for some more stories. As always.
Okay, here you go. The second Pleiades in the sky.
Second Pleiades?
The second Pleiades in the sky. Everybody knows the Pleiades, the Seven Sisters, Subaru.
Mm-hmm.
Now, it actually has a twin.
Okay.
And the actual real name of the twin is actually nothing that was romantic as the Pleiades. It's the Pisces Eridanus stream. Now, the stream itself is over 120 degrees across. So, and this is co-moving stars, and it took the precise measurements announced by the Gaia team to notice that all these stars are moving in the same directions. Now, many of these stars, like the Pleiades, are actually bright enough to be seen with the naked eye. And, of course, we know what the Pleiades looks like. 4 or 5 bright stars, some lovely nebulae. And, of course, it's iconic. So back in February, there was an announcement that they had spotted a group of hundreds of stars all moving in the same direction. They were spread out against the sky. And if you plot them out flat, that's what they look like. So if you look at the picture right near the bottom, it gives you an idea. The actual members of the stream are plotted in red, and the Milky Way is shown as being circular on this picture.
Mm-hmm.
Quite impressive, I think, Marty.
Yeah. Coming up, meteor showers, since we were talking about that a little bit ago. Coming up June 3rd, we got 2 of them. They're all minor showers, though. The Tau Herculids peak on June 3rd, and the Northern June Aquilids also. Well, those would be on July 3rd, sorry. June 8th is the June Me Cassiopeids will be peaking. And also on June 8th, the daytime Aretids peaking on June 8th. So a couple meteor showers, mostly beginning of June. If you see some, it might be part of a shower, might not be part of a shower, only if you track it back to those constellations. So
if it's coming from if it has a radiant that's in the constellation, then yes, it belongs to the shower. If it doesn't, it's just a random meteor shower. Meteor. Oh.
Yeah.
It's been a busy day today for me.
That's right. Hercules, Cassiopeia, and Aries are the constellations that they'll be coming out of. 5 minutes. We still got a little bit of time.
4 minutes.
We don't want to go too detailed.
Okay. K1 Atlas. What do you think?
What was it? Atlas?
Yep. It's a comet. It's 2019 K1 Atlas.
Okay.
However, it's a comet that's maybe not a comet. What's happened is there's been about a good 73 observations of this particular object, and it may be losing its cometary status. Why? Because it has an orbit similar to Oumuamua. And the moment they're trying to decide, is it fragments of Oumuamua, or is this a second interstellar object that we're actually going to get to see come through the solar system? Now, I put a link into the chat room. This is from the small body database from the JPL. 3 minutes noted. And it shows some very interesting stuff. And I am actually following this because initially I was planning to image this as a comet. And I think most people now are looking to image this as a second interstellar visitor. Well, actually, it's the third, because we know that one of the centaurs that Jupiter has captured, from the way it's been tracked back, was actually possibly an interstellar object that was captured by Jupiter. Mm-hmm. So Oumuamua may be number 2, this may be number 3, but it will be the first one for this year.
A couple things make that distinction. Its orbit needs to be almost a parabolic orbit or hyperbolic orbit, and its speed. So something really fast that we know that calculate can actually escape the solar system. In order to be able to escape the solar system, it must have been traveling fast enough to, on the inbound leg, to tell us that, when it goes out, it's going to get out of the solar system. So that would, a couple of things that determine that it's a interstellar object coming through. U.S. Post Office, by the way, is going to be issuing some moon landing stamps. So check those out, and they're what we call forever stamps. You buy them once, and doesn't matter when you use them. They're good for now until the end of the post office, I guess. And a quick one, Mars Curiosity rover found a cache of clay, not to be confused with Cassius Clay.
Muhammad Ali.
Yeah, indeed. So a bunch of clay was drilling into some areas on Mars, thought to be rocky, but found out it has a whole bunch of clay in it, which is always interesting. Clay means there was water there, and if there was water and dirt, potential of finding some maybe evidence of past life on Mars.
Hey, Marty, come start putting the kit away.
I think it is.
Yes, it is. So, I hope everybody's had a good evening and enjoyed the show and enjoyed the banter. I always certainly do. It's always nice to see people in the chat room. So I think it's probably getting close to that time.
It is.
It is,
30 seconds or so. Yeah. Thank everybody. Thanks everybody in the chat. Don't forget, we got more programming coming up after the event horizon, so stay tuned. And we'll repeat these programs of 4-hour slots for the next 24 hours. So appreciate everybody listening in tonight. We should be back next Friday. Hopefully we'll be having a Space Pirate show next Wednesday also. Go for it,
Captain
Nick.
7, this is the away team. Marty, Nick, and Starstorm ready to beam up. Bring us home, Captain 7.
Night all.
Good night all.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing, and all of a sudden, wham! Astronomy right between the eyes.